All right, these expressions contain products of binomials. What we want to do is try to keep track of the separate terms in our um, answers, I guess, as we get them. So when we look at an expression, we want to look at the separation in terms. Our terms are separated by plus or minus outside of parentheses. So like this first one in A, there's actually two terms and they're separated by the plus sign. So we're going to use that plus sign as a way to structure our work. So the first term on the left is a binomial, is two binomials. So we're going to multiply these binomials. The same thing we did with the smile method. The first term, x times x, gives us x squared. The last term would be 1 times negative 2, which gives us a negative 2. And the middle term would be an x and negative 2x. So the middle term would be a negative x. So when we expand this, we basically expand it into three terms. So the right side, we notice, is one term times a binomial factor. So we're just going to take this term and distribute the 3x to each of the terms here. So again, as we do that, we're going to actually create two separate terms. Sorry about that. So we're going to distribute and create two separate terms. So the 3x times x would be a positive 3x squared. And then the 3x times 3 would be a positive 9x. So we expanded both our terms. We have all separate terms. So now we can just combine like terms. So we'll combine like terms. We have an x squared and a 3x squared. That would give me a 4x squared. It looks like we have a negative x term and a 9x term. So we combine those to be a positive 8x. And then we have a constant left of negative 2. So we expanded this and combined like terms to get our answer. All right, the next problem B, again, we want to use the separation in terms. So if we look, the separation in terms would be right in front of the negative sign. That's the only sign outside of parentheses. So our first term, we could expand this. This is a binomial squared. So we'll use that pattern with the binomial squared. We know that the first term would be 3y squared. So that's a 9y squared. The last term would be a negative 2 squared, which should be a positive 4. And then the middle term is just 3y times negative 2, which is negative 6y doubled. So when we double that, we get a negative 12y. And again, when we multiply this, we basically expanded the expression into three terms. So the left side is expanded, the left term is expanded, so now the right term. And now here we need to recognize the negative sign in front is actually a factor of negative 1. We want to keep track of that. So the other factor are the two binomials here and here, and we notice they're conjugates. So this is actually really nice to multiply. We only get the first term squared, which is y squared, and then we get negative 5 times 5 or negative 25, no middle term. So now our terms, we do need to distribute the negative 1 to each of the terms. So now multiplying by negative 1, distributing to each of the terms, we'll get a negative y squared. And negative 1 times negative 25 would give us a positive 25. So again, just making sure we see the factors in the terms. That negative 1, since it starts with a negative, it's actually a factor of negative 1. So all of our terms are separated. We should be able to just combine like terms now. We have a 9y squared and a negative y squared. That's an 8y squared. We don't have any more y terms, so we got the negative 12y. And then the positive 4 and a positive 25 is a positive 29. Okay, so again, we're using the structure of the problem to help us keep track of our multiplications and our answers as we go. So the last problem, C here, whoops, excuse me. Again, we're looking at the expression. There's a negative sign outside of parentheses, so right in front of that splits our two terms. Again, starting on the left side, and again, it doesn't really matter, but we notice we have conjugates here. So we'll just multiply this. We get a times a, or a squared, and 9 times negative 9, which is negative 81. So that expands into those two terms. The expression on the right, again, starts with a negative, so that is a factor of negative 1. So I'm going to keep track of that factor as I multiply this binomial squared. So the binomial squared, I'm going to use parentheses to keep track of it. 2a, the quantity squared, would be 4a squared. The last term is a negative 4 squared, so that would be a positive 16. And then the middle term would be a 2a times negative 4, which is a negative 8a, but I have to double that, so I get negative 16a. So the last thing I need to do on the right side is distribute this negative 1 to each term. That's going to create 3 terms. Would have a negative 4a squared. Negative 1 times negative 16 is a positive 16a, and negative 1 times 16 is a negative 16. So each term, both sides of our expression, each term has been expanded. Now we can collect like terms. We have an a squared and a negative 4a squared. That gives us a negative 3a squared. Looks like I only got one a term, so that'd be a positive 16a. And then negative 81 and negative 16, when we add those together, we get a negative 97. Okay, so again, look for the problem structure, look for the composition to help you organize your work, and don't forget about that factor of negative 1. When I'm subtracting a term, that becomes a factor of negative 1.